Good day, students. So in this clip, we're going to be going over some questions to get you ready for the upcoming final test. So let's start out by taking a look at number one. Number one says use the given approximate values to find the exact value of the following. So we're going to do number one and number five. Okay, so let's start out with number one. So for number one, we're asked to find the value of log base p of xy. So remember, these two variables are being multiplied. So remember, whenever you multiply logarithms, multiplication in the log world, multiplication of numbers is addition in the log world, and division of numbers is basically subtraction in the log world. So in this case, you want to apply the properties of logarithms to this product. This is going to basically be equal to log base p of x, and then that times become plus log base p of y. Alright, now I'm going to substitute their corresponding logarithmic values and find the sum. Okay, so this is going to be approximately log base p of x is 0.3515, and I'm going to add it to the approximate value of log base p of y, which is 0.7123. Okay, and then when I add that up, I have 8, 3, 6, 0, carry 1, so it's 1.0638. Alright, so there goes your answer. Alright, let's move ahead to question number 5. Take a look at number 5. So for number 5, we are asked to find the value of log base p of x squared y. Alright, so for this one, this is basically going to be log base p of x times y. Okay, you notice we're adding two x's and then a y, right? So if I want to apply the properties of logarithms, remember when you're multiplying, the values is the same as adding the logs. So since we're multiplying here, we're going to have log base p of x plus log base p of x plus log base p of y. Okay, so since we have two x's here, it's the same as doubling it, right? So this, we can just write this as 2 log base p of x plus log base p of y. Okay, and another trick you can use this, make this go over there. So another way I could have done this, I could have written this as log base p of x squared plus log base p of y, and then I move this 2 to the front, and then I end up with exactly this. So whichever way you want to do it, just remember when you're squaring a variable, you're going to double the logarithmic value, okay? Because squaring is basically multiplying, and then if you multiply something by itself, is the same thing as adding it to itself in the logarithmic world, which is doubling. Alright, so let's put in the approximate values. So we're going to have 2 times the value of log base p of x, which is 0.3515, plus log base p of y is 0.7123. Okay, so let's evaluate this expression using our calculators. So let's do this. So we're going to have 2 times 0.3515 plus 0.7123. Final answer is 1.4153. Alright, so our final answer is approximately 1.4153. Okay, so there you have it. Alright, let's move on to the next set of problems within section 1. I'm going to work out number 16 and 18. Okay, let's start out with number 16. So for number 16, we're asked to solve a logarithmic equation. So for 16, we have number 16, we're going to solve log base 3 of 5 plus log base 3 of x equals log base 3 of 10. So before you do this, before you can eliminate logs, it must be consolidated first. So whenever you're doing logs, you have to first consolidate, just like you're consolidating your debt, you consolidate first, and then before you eliminate, okay? What do I mean by consolidate? I need to have only one logarithmic value expression on my left and one logarithmic expression on my right. Okay, so to consolidate these two, I have to use the whole idea that when I'm adding logarithms, it's the same thing as multiplying the values. So it's the same thing as multiplying these two values right here. Okay, so since I have a plus here, plus in the log world means that I'm going to have log base 3 of 5 times x, okay, equals log base 3 of 10. Now this has been consolidated because I have one logarithmic expression here and one logarithmic expression here. Now to get rid of this, I just exponentiate both sides using 3 as the base, since the base here is 3 and 3. So what I'll do is I'm going to have a big 3 on the left and a big 3 on the right, and the values will be exponentiated. So I'm going to have little log base 3 of 5x, and on the right side, little log base 3 of 10. The exponents or logs are inverses. These cancel out, leaving me with 5x. And this also cancel out, exponent and the logarithm, leaving me with 10. Divide both sides by 5. And your final answer is x equals 2. Alright, there you have it. Alright, let's take a look at number 18. For number 18, we have the expression, just bring the whole thing, so do that. So for number 18, I have the expression log base 7 of 24 minus log base 7 of y plus 5 equals log base 7 of 8. We have two logarithms on the left, so they must be consolidated first before I can eliminate, okay? So if you have a difference of logarithms, that means you divide, all right? So to consolidate these two, you're going to have log base 7 of 24 divided by y plus 5 equals log base 7 of 8. All right? Now we have a log and a log on both sides, the same base, so we just simply eliminate it by using the exponents, okay? Since you have opposite of log as exponents, I'm going to put a big 7 here and a big 7 here, and both sides will get exponentiated using 7 as the base. So I'll have a little log base 7 of 24 over y plus 5 equals 7 to a little log base 7 of 8. Okay? I just exponentiated both sides using 7 as the base because I have a 7 here and I have a 7 here as a common base. Since exponents or logs are opposites, these two cancel out. These two cancel out. And you'll be left with 24 over y plus 5 equals 8. I can just write 8 over 1 so I have a fraction on both sides. To do this, I can cross multiply or multiply both sides by y plus 5. So just cross multiply bottom to top, bottom to top. So I'm going to have 24 equals 8 times y plus 5. Alright? So I'll distribute this 8 to both terms on the right side. And I'll have 24 equals 8y plus 40. To get y by itself, I subtract 40 from both sides and divide by 8. Alright, so subtract 40. And that gives us on this side 24 and negative 16 equals 8y. Divide both sides by 8. And then you end up with y equals negative 2. Alright, so there goes your answer. Y equals negative 2. Okay? Alright. Now let's go on to question number... Now let's go on to station 2. So for this one, we're going to take a look at question number 1. Okay? Let's take a look at question number 1. We're asked to expand without using the binomial theorem, so we're going to expand question number 1. we're going to expand 2x plus 3y to the third. All right. So we can do this by foiling, but I'm going to do this using the Pascal's triangle. All right. So to do that, starting with the first one, I'm going to have 1, 1, 1. This is row 0. This is row 1, 1, 2, 1. This is row 2, 1, 3, 3, 1. That's row 3. Okay. So I'm going to line up my variables, my coefficients here. 1, 3, 3, 1. Why did I stop at row 3 is because I have a 3 up here. Okay? So this is row 0, 1, 2, and 3. Now I'm going to start with 2x. I'm going to take 2x to the biggest power, 2x to the third, and 3y has nothing. And then this starts to go down, and this starts to go up. Alright, so 2x drops down to the second power, while 3y goes to the first. 2x drops down again to the first, while 3y goes to the second. 2x finally drops down to 0, while 3y goes all the way up to 3. You see how the powers have switched. Alright, I'm going to expand each term and add my sum. Add my expanded terms, and then that will be my my final result. So if I expand this, I'm going to have, remember, anything to the 0th power, this is going to be 1. If I expand this, it's going to be 1 times 2 to the third x to the third, which is 8x to the third. This one is going to be 3 times 2 squared times x squared times 3 times y. So we're going to have 3 times 3, 9 times 4, which is 36x squared. And then this one is going to be 3 times 2 to the first times x to the first times 3 squared times y squared. This is going to be 3 times 2, which is 6. 6 times 9 is 54. 54xy squared. I forgot the y here. Put that in. And then on this side, this goes to the 0th power, so that becomes 1. So we're going to have 1 times 3 to the third, y to the third. 3 to the third is 27, so it's going to be 27 y to the third. Alright? So if I add these terms together, that will be my final answer. So my final answer is going to be 8x to the third plus 36x squared y plus 54xy squared plus 27y to the third. Okay? Alright, now let's move on to question 5 on station 2. On question 5 on station 2, I'm just going to set up the problem, and then you can finish it up using what we just did for number 1. So for question 5, it says that we are told that one side of a cube has a measure of 3x minus 5y. So find the volume of the cube. So basically, what we have here, we have a cube. Let me sketch a cube for you. So we have a cube, and we know the measure of one side. That, so let's sketch a cube here. So let's say we have a cube of this nature. Now the question is, what is the formula for the volume of a cube? Okay, so this cube is not perfect, but just pardon me for this. So if we have a cube, the measure of all sides, we can call the measure of all sides S, right? So this is all sides are congruent for a cube. We know that. All three sides are congruent. And then this is S. This side is S, that means this side is S. S. Okay? The formula for volume, the volume of a cube is given by S to the third, right? So the volume of a cube is given by the formula S to the third. So V is basically S to the third. So since each side measures 3x plus minus 5y, that means this side is going to be 3x minus 5y. The length, the depth or the height, and then the width is 3x minus 5y, and that is also 3x minus 5y. So using the formula, the volume is simply going to be 3x minus 5y to the third. So you just expand this using the Pascal's triangle, row 3, and then that will give you the final answer, okay? Don't forget to alternate the signs, plus, minus, plus, when expanding negative binomials, okay? Difference of binomials. Okay, now let's move on to number 7. Number 7 says find the coefficient of x squared y to the 5th in the binomial of the binomial 2x minus 3y equals 7. So we have 2x minus 3y to the 7th, and we're looking for the coefficient of x squared y to the 5th. So since this is 7, that means we have to go to row 7 in Pascal's triangle. So we're going to go 1, 1, 1. This is row 1. 1, 2, 1, row 2. 1, 3, 3, 1, row 3. 1, 4, 6, 4, 1, row 4. 1, 5, 10, 10, 5, 1, row 5. 1, 6, 15, 20, 15, 6, 1, row 6. And then 1, 7, 21, 35, 35, 21, 7, 1 for row 7. Okay? So there you have it. Now, it says x squared y to the 5th. What is the coefficient? So what we're going to do is we're going to line up all these numbers. We have 1, 7, 21, 35, 35, 21, 7, and 1. Alright, so we're going to look for the square in the 5th one, okay? So starting from the first one, we're going to have 2x to the 1st. I'm sorry, 2x to the 7th. 2x to the 7th power. Well, it's going to take me longer, so why don't I just start from the bottom since we're going to have square. So this is going to be 2x to the 7th, and then this is going to be 2x to the 0th power, right? Because this is 7, 6, 5, 4, 3, 2, 1, 0. Alright, so 2x to the 0, this is going to be 2x to the 7. Let me just put everything in so you don't get confused, okay? So 2x to the 6th, 2x to the 5th, 2x to the 4th, and then 2x to the 3rd, 2x squared, and then 2x to the 1st. Okay, see how it goes all the way down? And then negative 3y is going to go from 0 all the way to 7. So if I wanted to make this faster, I can just start down here, and I'm going to go negative 3y to the 7th, and then it starts going down, negative 3y to the 6th, and then negative 3y to the 5th. Okay? Now this is my target term to expand. That's why I started from the bottom. Why do I want to expand this term right here? Because that is the one that has x squared y to the 5th, like this question suggested. So if I expand this, I should be good. Alright? So this one is going to simply become 21 times 2 squared times x squared times minus to an odd power is negative, so the minus comes out, minus 3 to the 5th, y to the 5th. Okay? Now let's expand this. I'm just going to do the numbers in my calculator, and then we're going to have x squared y to the 5th. Okay? So if I put the numbers in my calculator, I'm going to have 21 times 2 raised to the 2nd power times 3 raised to the 5th power, and the answer is going to be 20412. Okay? So that's what the coefficient is going to be. So we're going to have the coefficient is going to be negative 20412. Alright? So the answer, the question asks me just the coefficient. So our answer is going to be it's going to be 20412. Negative 20412. Alright? Okay, now let's move along. Let's take a look at question 9. It says find the value of n if 10 squared x squared y to the 8th is the 4th term of x squared y squared n. So find the value of n. So we can cheat in this problem. Use Pascal's triangle to see which Pascal's triangle has a fourth term with coefficient of 10. So let's look at number 9. So what I'm just going to do is I'm just going to blindly create my Pascal's triangle and see which one has a fourth term of 10. So for number 9, I'm going to go 1, no 10 yet, 1, 1, no 10 yet, 1, 2, 1, no 10 yet, 1, 3, 3, 1, no 10 yet, 1, 4, 6, 4, 1, no 10 yet, 1, 5, 10, 10, 5, 1. Wait a minute. First, second, third, fourth. Down. This is the term we're looking for. So what row is this? This is row 5. So since this is row 5, that tells me that n is simply 5. Okay? So that's all you need to do. Alright, let's move along to section 3, where we're going to be using the sum and difference formulas. Remember, these formulas will be provided for you on the test. Okay, so let's take a look at number 1. Number 1 says find all the odd numbers between 102 and 203. So that sounds kind of complicated, but if we write down some of them, it will make more sense. So for number 1, the odd numbers from 102 to 203, we're going to have 103 is the first one, comma. The next odd number is 105, comma, dot, 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 comma, 203. Alright, so it says find the sum. So the sum formula Sn is going to be n over 2 times a1 plus an. Alright, as the formula here suggests. So I know that the first term a1 is 103. The last term an is 203. And, oh wait a minute, it says between. So since it's between, I can't include 203. I have to take out 203. So I have to go to 201. So 201, sorry, is the last one since it's between. So the an has to be 201 also. Alright? Okay, so sorry about that. Let's make an 201. Now what is n? N, I have no idea what n is. So since this formula doesn't work, we have to call in the help of the other formula, which is the nth term. So an equals a1 plus n minus 1d. This will help us find what n is, okay? Do we know what d is? Do we know what we add every time? If you're going by odds, what do you add every time? You add 2, right? So d is basically 2. Alright, so let's plug these information in here to find n. Then we'll have enough information to find the sum. Alright, so we're going to have an, which is 201, equals a1, which is 103, plus n, we have no idea what it is, minus 1 times the common difference of 2. Alright, so we can subtract 103 from both sides, and while we're at it, distribute this 2 to these two terms right here. Okay, so that yields 201 minus 103. Let me calculate what that is real quick. Calculator, where are you? There you are. So 201 minus 103 gives us 98. So we're going to have 98 equals, if we distribute that, you have 2n minus 2. Add 2 to both sides. Add 2, add 2. And then we're going to have 100 equals 2n. To finish it up, divide both sides by 2. And then we have n equals 50. So are we done? Absolutely not. We're just halfway. We know what n is. Now we've got to find the sum. Okay, so we know n is 50. So since n is 50, we're going to have the sum Sn is going to be 50 over 2, which is n over 2, times a1, which is 103, plus an, which is 201. Okay? And that's going to be 25 times 103 plus 201 is 304. Alright? So let's work that out with a calculator. 25 times 304. What? 304 equals 77,600. So you're going to have 7,600 as your final answer. Okay? Alright, now let's move on to another example. Question number Number 5 says, what is the sum of the following arithmetic series? So for this one, we're still going to use the same formula, but this is presented to us in sigma notation. So what we're going to do here is copy down the question. Number 5, we have the sum, the sigma sum from n equals 1 to 6 of 3n minus 2. All right, so to do this, we need the sum formula Sn equals n over 2 times a1 plus an. All right, so in this formula, to get a1, all you do is you take the lower limit and plug it into n. To get an, you take the upper limit and plug it into n. Okay, so a1 is simply going to be 3, plug in 1 for n here, times 1 minus 2, which is going to be 3 minus 2, which is 1. So that's a1. An is going to be 3. We're going to now plug in the upper limit, times 6 minus 2, which is 18 minus 2. 18 minus 2 is 16. All right? Now, what is n? How many terms are there from 1 to 6? From 1 to 6, we have 1, 2, 3, 4, 5, 6. How many numbers are there? 1, 2, 3, 4, 5, 6. So we have 6 numbers, so n is 6. All right? So let's find the sum. So S6 is going to be n over 2 times a1 plus an. Okay? So 6 over 2 is 3. 3 times 17 will give us the answer. 3 times 17 is 51, so there goes your sum. Okay? Lastly, we're going to take a look at question number 13. 13 says, what is the value of the following sums? So for number 13, you can notice something is unique about this expression. You have 1,000 plus 100 plus 10 plus dot dot dot. What does this dot 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 mean? It means that it goes on forever. So anytime you have a series that goes on with dot dot dot, this is an infinite series. Okay, it's an infinite series, and we can find a sum using this formula right here. It says infinite sum, and it only applies to geometric series, so we know that this is geometric. Okay, so the infinite geometric series formula that we're going to use is highlighted there in the box. This one is going to be S, sum of the infinite number of terms is going to be a1 divided by 1 minus r. Okay, so a1 is the first term, which is clearly 1,000. R, the common ratio, you get it by doing a2 over a1. Basically, that's what you multiply every time, so it's going to be 100 over 1,000, which reduces to just 1 over 10. Okay? So the sum of the infinite number of terms is simply going to be 1,000 divided by 1 minus 1/10. Okay? So 1 minus 1/10, we can write 1 as 1 over 1. And we can times this by 10, top and bottom. So it's going to be 1,000 divided by 10 tenths minus 1/10. 1/10. So the answer, the result is going to be 1,000 divided by 9 over 10. So since you have a fraction in the denominator, we're going to multiply by its reciprocal, right? So we're going to have 1,000 times, we reciprocate the denominator, 10 over 9. Okay, so we're going to have 10,000 over 9. Okay, so there goes the sum. There goes your final answer. All right, thanks for paying attention to this presentation. Remember that you can always subscribe to my videos and make requests. A collection of my clips are on mathgotserved.com, so that's where you can see all my videos. All right, have a wonderful day.